last but not least presentation from Bijan Mohammadi, Bondzai. Bijan is a professor of applied and industrial mathematics with lots of experience in industry research projects in the field of mathematical simulation and optimization. Invented a lot of algorithms in the deep learning field, and also model generator code for deep learning, and partnered with Alan Panet to build Bondzai, a company which is addressing AIoT through zero data set, deterministic, offline, event-driven, on-device learning paradigm, which is in the scope of today, with respect to intent-driven cloud-based deep learning solution. Has an extensive academic career, including a lot of awards, publications, PhD supervision, and principal investigation in public and private research lab. So the title of his presentation is On-Device Continuous Event-Driven Deep Learning to Avoid Model Drift. Bijan, the floor is yours.
Thank you. Thank you. And truly thank you for the invitation, tinyML community. The talks today actually did more or less my introduction. The keynote this morning, the presentation you made actually, and this is almost our pitch. So I will show you our view of what is on-device learning and why it is important. And I will try also to answer the question of how to label ground truth data. So the harsh truth of AI in industry, by the way, we are very much industry. The harsh truth is that almost none of the projects make it to production. This is, I mean, we had question on that by several realistic questions. And these are not all numbers. You have statistics on that you can find on the web. Why is that? Data set collection is a problem, especially in industry. You can never have the level of data, the amount of data, the quality of data you need in deep learning. Then you have all this model building, and we have here beautiful solution to ease the life of people in building model, training model, back propagation, etc. I mean, we have, in your community, you have plenty of nice solution, but still almost no project make it. Then imagine by chance you have your data, you have your training, you have your huge model, you have to optimize it. It's another harsh job to do. Again, you have solution here. And by this time, your management finds that there is no proof of return to investment. And by the way, my suggestion for tinyML is to have a session on ROI. Why there is no proof on ROI almost never in deep learning projects. So management basically quit. And if by chance you end up, like said several times, flashing your model, you face model drift, as it has been said several times, and your performance is not there. You have to restart over, and you have this kind of scheme back and forth, which is clearly not sustainable. So let's take an example, classical example of workflow for command, voice command, where you go from speech to text, then text to intent. Each of these models are huge, have been trained on huge data sets, are often very, very language specific, because data sets doesn't exist in all the languages. Technical terms are often absent from your data set. So you build your first model, you build your second model, you prune, you quantize, you do your optimization, takes weeks, months, etc. And you have operators, they have an accent. And this is the problem we have in France, lots of different accents. I imagine in US it's the same, between a nice Californian accent, a Texan, things are not the same. And basically you have to restore. It's not sustainable, it doesn't work. In industry especially. So what we can do to make things happening, going from 3 to 70% deployment. This is our target, going from 3 to 70. First of all, we have to remove that asset constitution. It's not just reduce it or something, we have to remove it, okay? We have to learn the data, capture the data on the ground, label it, or have the user label it, and lots of industrial application, the user have the operator has a position, has an action, which constitute the labeling. And you can look at in the supermarket, for instance, the lady pushing buttons, actually she is doing the labeling. So just take advantage of that. So this is why I'm saying we go to 70%, not 100%, because not everywhere this is possible, but lots of the time the labeling is already there, especially in industry. Model optimization, model building and optimization. This has to be only forward, no backward. I mean, when you go eval, test, and deployment, and by the way, everything in our case takes place on the device, there is no coming back. And the user should not have to intervene to do the model definition. I will come to that. This is fundamental. And to avoid model drift, of course, you have to learn all the time. Basically, in our case, every time we infer, okay, for every inference, we have the capacity to rebuild the model from scratch. One training at each inference. We can do that. So the mathematics, the core mathematics is called Diplomat in Bondzai. You know, this is what I invented. And the team, we are now a startup of 6. I am the only coming from the academia, all the others come from industry. Diplomat has a special convolution network, spiking convolution network. Spiking is important because there are functions, naturally they vanish. They are by nature spiking. Okay. There is only one type of layers, not different type of 1D, 2D, blah, 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 blah. Only one type of layer, so you don't have to think about it. You do not define the topology, the architecture of the network, and then do an optimization problem, okay? You do not do that. You have to do both at the same time. Think of 3D printing, okay? Diplomat networks are like a 3D print. And this is done because the user has no say, actually. He say, okay, this is my input. These are my actions which do the labeling, okay? And do your job. The user has nothing to do more than that, okay? And there is no backpropagation. To mention the first talk of the session, okay, this echo state network is a particular case of Diplomat network when you stop at just one layer. Okay, and this can be seen also as a Kalman filter. Mathematically, it's the same thing. And the other thing which is necessary if you want this to work is that you have to converge fast with the amount of data you need. If you need thousands of scenarios to learn, it won't work. It has to converge fast. This is the curve on the right. A few more characteristics. So as I said, it's zero data set. It's event-driven. Every time the user make so we work naturally in reinforcement learning. Okay. Every time the user make a correction, we rebuild the network. Every time we detect a change in the environment, the noise, the light, and anything, we rebuild the network, okay, automatically. The user has no intervention to do. As I said, no backpropagation. Maybe I take an example of analogy with what we have in solution of linear systems. When you want to solve a linear system, AX equal B, you have two classes of method, okay? Direct method, iterative method. Everything we do in classical deep learning is using iterative methods. Diplomat, like ESN networks, are similar to direct inversion of linear system. Okay? There is no third party. Things have been developed, no third party libraries. Everything have been developed by us. It's deterministic. I really liked your introduction. It's deterministic. There is no stochastic component. So each layer is deterministic, and it's based in a mathematical formula. So the keynote say, why do you give this decision this morning? In our case, we have a proof. It's like classical validation of codes in engineering. We can certify everything we do. So there is no hyperparameters, of course, I said, because there is only one layer types. The building is done automatically, and the building stops once we reach a target level of learning error, with the constraint that the validation error does not increase. And the kernel, I mean, the footprint is like 50 kilobytes. Okay, so this was the kernel. The product, so we are a company, we have a product. The product is called DaVinci, and it comes at its core with Diplomat, and it provides you with everything you need to deploy. Okay? We said that we want to deploy. So we give the user the possibility to deploy. Okay, forget about, by the way, we don't say that we do AI. Okay? We deploy AI. So it's real time. It comes with a library of feature extractions, but you can plug your own. Zero data set, I do not insist. Collaborative. This morning, the keynote said two things which are at the core of what we do. If you want to break the complexity, you have to do two things. Decompose and abstract. Okay? Introduce abstraction. What is introduce abstraction in our case is to use a single type of model, which encapsulates everything we do in deep learning. Okay, all the different characteristics of the different layers. This is abstraction. And decompose is what? Is when you have a big problem, slice it in small problem, and use collaborative connectivity between the different models. And this is what we offer. So today, the talks were perfect for me because it's a perfect introduction. So we have supervised learning, of course. We can load data sets. We do semi-supervised if the user provides one example of each case. We build from this. Reinforcement, the user, as I said, the lady which punches the button, reinforced. Okay? Every time there is a punch, the motor is regenerated. And we have also unsupervised 4-time series. Okay, and it runs on microcontrollers, and for ours, the supercomputer is Raspberry. Okay, our supercomputer is the Raspberry. So we work from Raspberry to everything else. So our customers are mainly industrial. So we have several of them are ongoing. And I will discuss especially on the one on the left. On left. Voice command in industrial environment. So I come back to my problem of command. Remember, speech to text, text to intent. We do speech to intent. This is what we advocate. Because we are especially interested by specific vocabulary, and this gentleman doesn't need a full dictionary. He usually manipulates 10, 20 target, sentence, or command. But you have to operate in extremely high noisy situation with accent and very, very strange words. And you have to be able to personalize the working space. And when we do that, if you are situation calm, there is huge, a machine works, and there is huge noise, your performance drops, okay? You learn the noise, by the way, you know that to learn the noise, you can do either the data augmentation or denoising. Okay, we don't denoise. We always add the noise to the data. And we don't do data augmentation like the way people does, adding new scenario to learn. No, we just add the noise we capture. Okay, there is a VAD, okay, which captures the noise when there is no speech, then it needs noise. Well, we add that to the commands the user have been previously recording. Okay, so it's noise plus command plus noise. And if the user speaker ID has been identified, each user has its own model. Okay, and this is how we can reach a very, very high accuracy regardless of who's talking, because each speaker has its own personal model. So let me discuss this competitive landscape. On the left is what we do usually, okay, to compare models, approaches. Static on a data set. You take a data set, you learn, then you test, and you compare, okay? So this, we compare with 3 major commercial solutions. Some of them were present at the conference. So, okay, we are comparable. But this is not what our game. Our game is on the right. It's the dynamic game. It's not the static game. Okay, on the right. So we start with the model we have on the left. And we have introduced 2 types of perturbation. The first perturbation, imagine the operator put a mask. Okay, it's a change of his voice. Boom, drop of the performance. By the way, our model performed even worse than the static model, which is the best second model on the left. Okay, but so we have the oscillations are due to the fact that we test with this mask all the data sets. Okay, this is not just one answer. We tried all the words to see the performance. Okay, then we asked the operator to do reinforcement. Okay, with this new mask, like what I did. With this new mask, he will pronunciate his commands. Okay, and you see that, and in 1 second, basically, the jump, it takes 1 or 2 seconds. We rebuild the model and recover the performance we had without the mask. The second type of the perturbation is noise. Okay, we go from 20 dB to 3 dB SNR. Okay, signal to noise ratio. And again, boom, drop of performance. And like I said, we add the noise which has been captured to the command which was recorded. And again, we recover in like 2 seconds, new model, recover the performance. Voila, this is our game. If you want to see how this works, there are several videos on our website describing diplomat versus classical deep learning, how to use live data. This is text independent. The other example was text dependent. Okay. Speaker identification, avoiding detection of spoofing. Okay. What are the resource footprint? This demo has been done on a STM32 and with 80 megahertz and 100 kilobyte of RAM. And how to avoid model drift, okay, with continuous learning of the noise. So there are 5 videos you can go through to see the performance. Voila, I think I passed my message. I would like again to thank the community for the invitation. See that continuous learning for us is definitely the way to go for in the future. Not because we are saying it, but because I think this is the only way to address this problem. We think that there is also a way to improve the interaction between human and machines, and this is actually something comes in a recurrent way from our customer industry. They want to pass the knowledge of the operators to the machines because of this problem of people retiring and the knowledge is lost somehow. There is a huge demand for that, the transfer of knowledge between elder and new workers. And the footprint of our AI is basically 0. We use the power which is more or less idle, because most of the CPU or the processors on the sensors are already too powerful. We can work on what is already there and basically bring the cost of AI in terms of energy to zero. We see you can. I mean, I really liked what said was Bondzai yesterday. I think if I remember. Say a few people can change the course of the things, and we think that we are doing something like that. Thank you for the invitation.